We are back with another video. Okay, basically in today's video we will be dealing with motion in circular orbit. Given that under the influence of a central force at point O, a particle moves in a circular orbit which passes through the origin O as shown in the figure above. Alright guys, the diagram here illustrates the motion of a particle moving in a circular orbit. Okay, as you can see here, from 0 up to 2a, we have something like a line passing through the center, and we call this a diameter. Therefore, we certainly conclude that the whole of angle P is nothing but 90 degrees. And if this is 90 degrees, guys, this angle will be opposite to this side, and if this angle is opposite to this side, we're gonna conclude that this side is nothing but the hypotenuse side of the triangle, and this side R will be the adjacent of the triangle. And the question says that show that the force varies as the inverse fifth power of the distance from O. Of the distance from O. Then we're gonna use the differential equation of the orbit. Here is the differential equation of the orbit. Second derivative of O with respect to, second derivative of U with respect to the variable theta plus the variable U equal to -1 upon ml squared U squared F into inverse U. And we will use this one as well. U is nothing but 1 over R. And from the diagram, we're gonna conclude that, we're gonna construct the equation for R. Then the equation for R will be this is the hypotenuse side and this is the adjacent side. Then we're gonna use the cosine trig ratio, and if we use cosine trig ratio, we will get something like this: cosine theta equal to R divided by 2a. Cosine theta equal to R divided by 2a. This tells us that in place of R, we're gonna replace it by 2a cos theta. 2a cos theta. Then if we replace R by 2a cos theta, we're gonna get U equal to 1 divided by 2a cos theta, something like this. However, here we have the second derivative of U with respect to the variable theta. Then we have to, comparing with this, we have to make cos theta. We have to transform cos theta because theta here is the denominator, and for us to derivate, we must make it the numerator, meaning that we have to transform this into 1 over secant theta. Then if we change cos theta, we're gonna get something like this: secant theta divided by what? Divided by 2a. Yeah, we will get something like this. This is the nice equation, as you can see. And from the differential equation, we have the second derivative, meaning that for us to get this one, we have to derivate U twice. Then the derivative of U twice will give us something like this. The first derivative will be du over d theta over what? Over d theta. Du over d theta equal to, then if we derivate this for the first time, don't forget that the derivative of this is nothing but secant theta tangent theta, then we're gonna get secant theta tangent theta divided by 2a. This is the first derivative, and let's quickly find the second derivative of u. Then the second derivative of u, we're gonna do it like this. We will derivate this again, and we call this the derivative of the derivative. Then if we derivate this again, we're gonna get second derivative. We will get something like d squared u divided by what? Divided by d theta divided by d theta divided by d theta squared, something like this, equal to, then if this tells us that we are going to derivate this again, and if we derivate this expression this time, remember, if we have two or more functions that are multiplying each other, then we gonna use the product rule. Then to use the product rule, we are going to derivate one function at a time, keeping the other constant. Then if we keep this constant and derivate this one, we're gonna get something like this. We're gonna get something like this, guys. We're gonna keep secant theta constant and derivating tangent theta. Then the derivative of tangent theta is nothing but secant squared theta, plus, this time around we're gonna keep tangent theta constant and the derivating secant theta. Then the derivative of secant theta is nothing but secant theta tangent theta. Then the derivative of this one will give us secant theta tangent theta. And don't forget that we have tangent theta, then tangent theta all divided by what? All divided by 2a. All divided by 2a, guys. All divided by 2a. And here we got the second derivative, which is this one, and our u is this one, meaning that now we can replace second derivative with this expression and u with this expression. Then let's and meaning that u inverse u is nothing but r. Then we can write this as f into r, f into r equal to negative ml squared u squared into second derivative of u over d theta over d theta squared, like this, plus the variable u. Here we're gonna have it like this, and this is equal to negative m l squared u squared inside the parenthesis. Don't forget that we have this expression and this expression, but if you check well, we have the denominator is the same, is 2a, then we can write it like this. Secant cube, because here we have secant and here we have secant squared, then it will give us secant cube, then it will be secant cube theta, secant cube theta plus what? Here, don't forget that here we will get plus secant theta tangent squared, because of tan and tan, then we will get tangent squared theta, yeah, something like this. And our u is secant theta, then u will be plus what? Plus secant theta, yeah, something like this. And the denominator is the same, the denominator will be what? Will be 2a. The denominator will be 2a. We have it like this. Then this will be equal to what? Will be equal to negative ml squared u squared divided by what? Divided by 2a. We take 2a outside, then here we will be left with don't forget that here we have secant squared, and we have secant cube, and this side we have secant, and secant we can take secant out, then we will have something like this: secant cube theta, secant cube theta plus secant theta plus secant theta outside, then inside we will have, here we will have tangent squared what? Tangent squared theta, and here we will be left with 1 plus 1. Yeah, we will have it like this.